Okay, cool. So, in the last video, I pretty much did this a little bit, but just to find out how the departments work. But we went ahead and I showed you how to find a frequency distribution as well as the histogram that corresponds with it at the same time when you had data. Okay? So if you histogram right away and you know the answer to everything, but I went ahead and showed you by hand, by scratch, how everything's coming together. And then from there, how do we actually draw a histogram if you have a table, and also if you had a table, how can you draw the corresponding polygon? Or if you had a histogram, how do you draw the polygon that corresponds with it? So now over here, we're going to avoid the polygons from here, but we're going to be drawing more histograms, but we're going to be focusing on the frequency distributions. How do we obtain them, how do we build them, and how do we graph them? And we're going to notice how, when we're doing that, we have to keep very mindful note of the scaling and how the scaling changes. Because once again, if you read the book, the frequencies could be any values. It could be in the hundreds, it could be in the 200s, it could be in the 300s. It could be anywhere based on how big the number of versions you have, or sample population you have. But when it comes down to proportions are going to be between 0 and 1. Okay, and we'll see that. And when you do percentage is going to be values between 0 and 100. So we're going to definitely see how the scaling is going to have to adjust and change as we do these problems, as we make these graphs. And we'll see that in different pages. And pretty much this is the main focus for this portion. How do I use by hand? How do I do by technology? How can I make technology more efficient in terms of me getting this task done in a more efficient and quick way? Okay? So understand the process, because once again, the process is key, especially when you're doing technology. And we'll see that. So, first thing first, let's go ahead and see what's the damage. So, now we have to use the table, and we made this last time when we had the data is still there, we still have the same information as before, and which we primarily said that, the lower limit, or the first lower limit was supposed to be 10, and we see 10 right here, and we're saying that the class width was supposed to be 15. And that we got from noticing that when I were to add 15 here, okay, it gave me 25, and when I added it again, it was consistent, and it gave me, erase that, make it better, it gave me 40. Well, I'll show you how, last time, how we find it by hand, and that was pretty much saying, look at the row limits, or aka the consecutive lower limits, and we can see that, when I got the row limits are out, okay, the difference of the lower limits, the difference of the lower limits are out. This right here was going to equal interval size, or class size in this case. When I say interval, I'm assuming class is that it's a range of common intervals. Interval size. So what we're seeing is, the row limits that we're looking at here for the first one was pretty much, we saw 24 minus, wrong with 25, the row limit, not the upper, but the real upper limit, minus the real lower limit, which is 10, and that is 15 in respect. And the same we see for the next one. The real upper limit for the same class was 40, minus the real lower limit of it was 25, and that is also 15. So let's check it out. So therefore we know our row limits. We know that we have our class width. Just by looking at the row limits. So we're going to recap on how we got this, guys. We talked about scaling and how these work, but we're going to be doing it based off the table now. The table that's provided, not from data. So I'm not going to use data no more, that it's still there, because everything here could be done through one same data. We'll see that. And pretty much from table, how do we do things? So first thing first, I'm going to graph this on the table, on the graph, the calculator, and then we're going to bring it over. But what I'm doing here is I'm making a new document, because I don't want to get this mixed up with the other ones. I don't want to make any changes that's going to harm things. So I went ahead and saved the other one prior. It was saved earlier, and when I saved it, when I opened up the new one, it's asking what I want. Remember, I want three things. The three things that we want is definitely I want the calculator one, I want the list and spreadsheets, and I want data and stats. Those are the three that I want. So I'm gonna start with the calculator one first. So I'm gonna enter that. So, but no, I have no other options. But remember, that's all under home. So go back to home, or you could do actually I could have added a page. That would have been another way of doing it. So I'm gonna just go to current, right here. I'm gonna do current, enter. So that's a current document, and I'm gonna do add a new page actually. So I'm gonna do plus or control, add a new page, and that's another way of doing it. So you don't have to do the menu. You can just do it here. I think it might be a little more efficient that way. And therefore, I want to do the spreadsheet, which is 4. I can either highlight it or press 4. There's my spreadsheet, but I also want my data sheet. Or when that could be made after that, but don't worry about that because I'll constantly make more and more data sheets. I'm going to say data, stats, and stats and data. So we'll come over here. Let's just go ahead and go. We're going to make our list right here. We're going to put it here, and then we're going to graph the first one. So right here, well, we know it's supposed to be the lower limits, but I'm just name it L1 for simple sake purposes. So L1 goes for the first list that we're making, and then right here is going to be all the corresponding lower limits. So I'm going to look at these lower limits right here, and I'm going to put this under L1. At the same time, I'm going to get the corresponding frequencies to the intervals, and I'm going to have it be L2. Okay, so we definitely could see the differences within the rank within them. And when I make the list, I know where they're coming from. So therefore, let's go put this in here. So we can add 10, enter 25, followed by 40, followed by 55, followed by 70. Well, those are all the class lower limits. There's five variables, 5 classes. So therefore, all we need is 25. So now we put the corresponding frequencies. So first limit, the lower limit should be 10 to the 6, and then 25 will take on the 7, and continuing 4 to 1. So you press down and enter to finish writing and entering the value, and then get to the next line. So we have that. Oh, but we gotta do one thing. Notice how I don't give a label here. So when you try to graph it, it won't be able to find it. You have to have a label so it could find whatever list you have labeled. That's the difference between the calculator, this one here. You're free to label your list any way you want, but you have to label it in order to use it. Okay? So over here, go to L2. So I'm gonna make L2. Oops. Delete. And when you're making these, put in the wrong spot. Smart. Let me delete that. Okay. Up in here, go to the top where the labeling's at, and I put L2 here. Whatever you do, don't put spacing. If you have multiple words, and I give it a hint. If you have multiple words that say that you want to put lower limit or whatever, or that won't be the case, but we can put time, and you want to put a note that's in minutes, you can't put this underscore, and you can, you have to put this underscore. You have to put this underscore minutes. Okay? And what it'll do is it'll know that this underscore means space. So you can't space it. The space is an illegal move. And you can't put decimals. You can't put any other symbols under the underscore. And that indicates, oh, it wants a space. And it will do that. Okay? But that's one thing label. So also, I don't want to go that big into the very end when I'm done. And I can't install minutes. Sorry about that. So that's a lot of labeling, and you want to avoid that. So I'd rather, for this one here, I'd rather use list 1, and then when I'm done with all my graphic labeling, I'll relabel it and it will work. Okay? Everything is transferred to the new label. So, with that said and done, I got this situated until about 2. There we go. So now I'm going to graph. So what I could do here is I could set up a new graph, but right here, since I'm doing a histogram, like the regular, I could just go from here. And what I'm going to do here, once again, I'm going to hit menu, and I'm going to go to data. Menu and data. Then I'm going to enter, and then I'm going to do, I'm going to do summary data, summary plot, enter. And what I want, well, this 2 is supposed to be frequency, it's not supposed to be the values of x, so I gotta make sure I label that correctly. So I'm gonna enter it, and make sure it's this one. It's selected, this one is selected. Then I'm going to go into the next one, enter it, and it should be list 2, that's supposed to be the frequency. So when you think summary list, that is the count, the frequencies. A count is the form of summary. A frequency is a form of summary. So put it in the summary list. Everyone just said frequency list, but remember, we've got different types of summaries. And so frequency is now been taken away from here. And then lastly, display, don't do split, make sure it is in different page or new page. So we're going to new page and highlight OK and enter. So we have a histogram, well, quite frankly, it's not the best histogram because if you look over here, it's going based off ones. And something's interesting here. What happened here? Why not this 1 and 2 separate? I messed up. So what we do over here is I could change the list 1 and 2 from here if you mess up like this. Notice how I have an error. Over here we have the list 1 and list 2. I'm trying to figure out how that happened. I could have said list 1 for the first one. I must have said it wrong. But it's okay. I do make errors. So over here, this right here, I'm going to click on it and I'm going to make it correct. So instead of being list 2, I want list 1 to go here. So, and then over here, it's supposed to be list 2, but nobody's going to put it this way. And that is weird. I might have to adjust it. I think this one is shot. Oh, yeah, it's shot. I definitely shot this one. So I do apologize. This one here is Connor's. What if I knew how to delete it? That'd be nice if I could just delete it. But it's done. I messed up. Okay, so I'm gonna go back over here. Okay. And I'm gonna do it correct this time. See, list 1 and list 2 is what it's supposed to be. So I'm gonna do menu again. Data. Go to summary plot. So once again, the X values is supposed to be this 1. So over here, I have to make sure I'm choosing this 1. And over here, I'm supposed to make sure I'm choosing this 2. And then come over here, I want to make a new page. And okay. There we go. So I must have done something wrong. I know I did something wrong because it was showing this. So I must have messed up in the selections. But once again, this is bad. It's like a bar graph. I don't want a bar graph, I want a histogram. So this graph is connected bar graph. If you're graphing this, you're getting points off because this is not histogram. This is a bar graph. Keep that in mind. Bar graphs have separate graphs that separate categories. A histogram has connected bar graphs that continues the flow of measurements. Okay, that's what histograms do. It continues the flow of measurements. So we have real limits, or in this case, boundary points that separate them. But anyways, come back over here. We go to menu once again, and I'm not going to change the plot type. I want it to be histogram, and notice it is a histogram. It is a histogram, which is 3. So I'm not going to worry about that. I'm going to back it up. But I'm going to go over here to properties, and for the histogram property, I got to make sure that I adjust my bin settings and make sure that it's equal bin settings. So now I can do over here is width was supposed to be 15, so I'll make it 15, and my alignment is supposed to be at the lower limit, the first lower limit, which is 10. That's good. I can now highlight enter and equals. There we go. Once again, this graph here is still not really good because you definitely see pieces over here missing. This scaling is not too it's not too decent, but it's still okay. So all right, we gotta do, how do we adjust this? It's always under windows. So make any type of adjustment with the window, it's under windows. So I'm gonna go to menu and I'm gonna highlight windows and zoom, enter, and I'm gonna change the settings in the window. So over here it says min 7.5, I'm gonna put that back at 0. And max, we'll just put it at 100 like I did last time. Okay. And over here, max, I'm gonna put that at 8. For the y value, 8. And highlight enter and equals. And now the graph looks a little more better than what before. So almost cut off, this is more presentable. Now what I gotta do is just renable these guys at the end. But once again, you can always do that once you have captured it and imported it into a Word document of that something could be done easily within it too. Just by putting text on top of it and writing over it. But anyways, there's my histogram. And it should be consistent. Well, the first one makes sense. The row limit is 10 and 25. Therefore, the upper limit for the was supposed to be 24, and the frequencies are the same. So it is matching. It is mimicking to what it should have been. So now we can definitely graph this over here if we chose to. And markers. But remember, always the y-axis is the frequency, and the x-axis is supposed to be your measurement, and that's what we have over here. The measurement was that corresponding with the lower limits, and the frequency was L2. So all we gotta do is just label them here properly. So our frequency will go here, and we know this on the y values. And if we are scaling, our scale, we had it made out of 2, because that's where the grid is at. So ours is out of 2, the grid line. And the max that we went for, that we obtained, was 8. So we're going to do the same thing. So over here we have a 0. This next grid line was supposed to be 2, then 4, then 6, then 8. Okay, because that's our scale. And therefore, on the bottom, that we keep it consistent, we're supposed to be the x values. So now we're talking about driving time. Driving time, and we know the driving time is in minutes. So I'll just write it in there, and we know this is 30, your x values. So now we definitely put in our boundary points, the corresponding boundary point that goes over here. So if I want to recap on the boundary point, remember it is halfway between the upper and lower limits. And or you could just simply go halfway and then just once you see the pattern, just decrease each row limit by. And also here might go upward. So so over here halfway between 24 and 25 was 24.5 that we found before. So over here, this one here was between 39 and 40, which is supposed to be 39.5. So now we see the pattern. Once again, it's 0.5 again, still. So therefore, we go 0.5 down from the upper limit, or upper limit, making it into 54.2 or 54.5. There it is. Same over here, halfway down, it's going to become 69.5. Over here, we understand the real limit for this one here was supposed to be 85. That's the real upper limit. So if I go halfway from there, it should be 84.5. And I still remember I define a corresponding real limit boundary for this lower limit here, which is halfway down, making it 9.5. So we have a limit. So one of the upper limits is permanent the real limits are permit all the lower limits. So once again, your book does boundary points, so I'm gonna keep the boundary points, but always adjust to what is it your book is doing, or your teacher. Right. So I got this as enter. So now I can draw my histogram like I did before. So once again, 6. So 6 is right there on the grid line. So I'm going to keep it consistent. There's my rectangle that goes to the grid line. Might be a little off, but just try to make it as nice as possible. Next is 7. Well, 7 is between 6 and 8. 7 is literally right here again. So halfway between, I'm going. There we go. And I connect the rectangles. Next was 4. Well, 4 is on the grid line. So I'm going to do the same thing. Connect the rectangles. Next is 2. Well, 2 is on the grid line. So there we go. And lastly, 1 is halfway between 0 and 2. So I'm going halfway up, and I connect the triangles. The only time we don't connect triangles is if there's a gap, and we know for a fact that the frequency is 0. When you see frequency is 0, well, it clearly says there's no height, so therefore that's the only time we have a gap. That's the only time. Other than that, they're always connected, like you see here. So the difference is 6 here, a 7, a 4, a 2, a 1. So what we see here is this is the standard scale for the frequency, but we're going to realize that when I go into the rounded frequency for proportion and rounded frequency for percentages, or I'll just say in your case, density. So when I say proportion, it's density for yours. This guy is going to have to rescale itself because once we're in different rounds, we're in different scales. We have to always adjust our scales appropriately. So this is first go ahead and say, okay, how much get rounded frequencies and how much get my percentage after. Now pretty much be doing that over here and then using the calculator to get pretty much the rest of it. Okay. So first thing first, rounded frequencies proportions. What understand in art it's called density. So I'll put a note here. Proportion, density, same thing. But let's get that first out the way. So we're doing relative frequency, and I'm doing it for proportions. Your book uses proportions. Keep that in mind. And we just here as a little note. Proportion is the same as density in the calculator. They're the same thing. But you won't see this unless you do the stats. If you do the actual data and you have a choice, it will be density, frequency, or percentages. That's the time it comes in. So that's what I'm doing here. Next, so come back over here. So how do you find relative frequency proportion? So in a proportion, it's found by getting the frequency of the corresponding intervals that we're looking at, and we're going to divide it by the number of observations, which happens to be the sum of all frequencies if you have data. If you do the number of observations, we'll count them up and we'll do it, but over here we don't know it. If we have data over here, well, if we add these guys up, it should equate to what's over here. So that's what I'm put over here as a note. Number of observations is pretty much the sum of all frequencies. Later on, this n is going to become the population, the population size, but for now, we'll just leave it as observation number. Okay? Some variables will be used and be saw as different ideas. So what are we saying here? Well, if I'm looking at interval, the first interval, which is from 10 to 24, this was our interval per minute, or class per minutes. And then we had our frequency over here. That was 6. So how are we going to find the relative frequency? Well, we're going to find the relative frequency by pretty much getting the 6 and dividing it by the sum of all frequencies. We have to figure out what that is. And I should have had some space for that. But I'll put it in a block for right now. So if I'm doing the sum of all frequencies, our frequency we're seeing over there is 6 plus 7 plus 4 plus 2 plus 1. And if you add all this up together, it should equate to 20, the number of observations we have. So over here, we put 20. Depending on how we put it in the calculator, it might put it as a fraction, and it's implies when it becomes 3/10. But the corresponding decimal that we use most of the time is going to be 0.3. I'm going to see how that happens in the calculator. Just go ahead and bring it, turn the calculator back on again, or bring it on the state if yours is not off. And we're going to go back to our calculating page, which is the first one. I always have my first one be the calculating page, and the second one be my data page, so I could know which one is which. So in here, well, let's do this calculation. Well, there's two ways of doing it, and we're going to see it. The first one I'm going to show you is the fractional one, where you put it actualize the fraction and see, hey, it looks like it might just be do this, or it might, the calculator might just go straight here. We're gonna find out, okay? We're gonna see 6 over 20 versus 6 divided by 20, okay? One of them definitely see a fraction, or a decimal, and the other one most likely might lead to a fraction. And we'll see right now. So if I just do the 6 divided by 20, and enter it, notice how it makes it into a fraction. So, the question is, which I should have learned, but I totally forgot to in this one, I covered the other stuff, is how to convert. Okay. Let me just see real quick, if I can come over here. No converting, this is all other good stuff. Well, I'm actually, might actually be here. Conversions, nice. Am I actually being here? Let's see. See density. Let me just convert this symbol. That might just be the easier way to do it, convert the symbol. Let me just enter that. And, oh, see, answer convert. So what's going to convert to? It should convert to a decimal. Let's see if that happens. It's in text, yes, okay. And it's not working. Dang it. So once again, I'm going to be here. Let's see what did it work for crowd. I'm going to put it for C. You better read this one. No, these are just different type of conversions. Okay, well, I guess it's something else I have to figure out how to work it. Supposed to be just going straight to decimals, but it didn't happen there. So let me just go ahead and escape it. And look for this. And what I'm going to do instead, I'm going to do the fraction, see what the fraction does. Because it's supposed to be giving 2 different answers. I was shocked that won't give me the fraction answer. And no conversion symbol here, which they should have it out here. So I have to find it. But let me just do the fraction one. So when you're going to do the book, the one on the left side of the book, and hit the fraction that's right there. Enter it. And I'm going to do the same thing, 6 divided by 20, and enter it. And it find how it still says it's a fraction. It would be great if you could just convert it and not, oh, but there's the fractional operation. I see it now, it's right there. But what's the conversion? Let me do, none of those guys. Well, I'm not going to stress too much about it right now. I'll definitely learn that soon. I just can't believe this is happening. It should be accessible here. I'm not having to do it like a treasure hunt. Let me see this real quick. What's that? Okay, let me just check something out here. Where's my settings? I don't know. Exit. I'm going home. Go to settings. Hopefully in here I can change. I'm done playing around with it. I do apologize for the waste of time, but what's supposed to have happened is it's supposed to have converted to a decimal. So now where the conversion is over here, I don't know, but that's one of the flaws that this calculator has, is we have to convert the symbol ready for us, so we can actually be able to go back and forth. So, I'll figure that out later, and but I know that's all for each one of these guys, so don't sweat it too much, or simply just get in a calculator and do it yourself, and just convert it into a decimal, and then I'll figure out where it is. Oh, approximation. I think I found it. I'm smart. If that's the case, I should have noticed, instead of looking for the conversion symbol, I should have gone for the approximation. Okay, they go to current. Let me see this now. Clear this. And then we just do the approximation right here. Second show. There it is. Wow. I'm looking for the conversion symbol, and it's the approximating sign. I do apologize for it. It's right there. I'm sorry. So that's how to get that to work. Right there. That's my fault. Okay. And pretty much doing this all at once, individually, that might take some time. So there has to be ultimatum. What is the ultimatum? Well, what we can do here is I can call upon list like before, list operations. So what I could do over here is notice how when I go to menu and I go down to statistics, okay, I have list math and list operations. Okay. So what I'm doing here is to find the sum, and want to find the sum of the list. Well, first of all, here, what I should be doing here, I should be first showing you guys how to scroll it back. I'm going to show you guys how to bring up a list. So if I this is on list, frequencies on list 2. So if I do list 2, and I just write that just the way it is, and I enter it, it's going to give me the set of all the frequencies in the list. So whenever I'm doing an operation here, and I do list 2, it's going to do it for each and every one in here. I'm going to see that happen. So when I go and find the sum, I could find the sum by going to stats, entering it, going to list operation, it's in this math, and we have here sum of elements. We're going to look at sum of elements. So I'm going to highlight sum of elements, and let's say sum of what elements? Well, I want it to be list 2's element, so I'm going to type in list 2. So L2 gets typed in, and notice how we get the same answer, 20. That's an alternate way of getting the sum, and we just add them all up, which is pretty nice. I like that. I like how that's done. Next, so how can I call upon this idea, okay, for all of them? Well, I know that the sum of all the frequencies is 20, so I could simply write 20 or write the sum of L2, and this here is going to be L2, and we'll see that. So what I'm doing here is I'm going to write, first of all, I'm going to write L2. Well, I should put in parentheses first. So this is the first. So L with L. So the parentheses, L2, L2. There we are. I'm going to go outside the parentheses. So I want to be sure that I call upon the parentheses to the L2 first. That's what's important thing. Then I'm going to divide by 20 and 20. Because that's what we had it to be. The sum was 20, so I divide by 20. And now I enter. And I get everything divided by 20. So I know what each corresponding fraction is for each proportion. But I don't want the fraction form because that's when we convert to decimals, it'd be easier to have it in decimal form. So how do you convert this to decimals? Well, I'm going to do something I did before, and I'm going to hit this approximation right here. So I'm going to hit Control, approximate, and what it does is every fraction that was in here, they made to a decimal. Isn't that amazing? So instead of having to do all of them one by one, we can have a list and we can call upon them at the same time. And all we need to do is for each one, just write down the fraction, which is what I'm going to do over here. So come over here, I'm going to put down the fraction setup. So we're going to have, for the first one, it was supposed to be 6 over 20, which is for this guy. We know it simplifies to 1/3, 3/10, but I'm gonna go with the decimal form, which is gonna be 0.3. Next, I have 7, and then divided by 20. And that's gonna give me what we have up there, which is 0.35. Over here, same thing, I'm gonna get the, it's supposed to be 4 divided by 20. And then there is supposed to be 0.2, if I'm not mistaken, yeah. 0.2. Next, we have the 2, divide that by 20, which is going to give us 0.1. And lastly, 1 divided by 20. One divided by 20, and that's going to be 0.05. So notice how I had it here. And I wait, can I put that to a list? Can I take this and put it to a list so I can be able to graph the wealth of frequency if proportion if I want to? And one thing I'm going to note here is if they don't have the percentage here, it's a big proportion, but once again, we see proportions if it's numbers between 0 and 1. Percentage, we're going to notice percentage be valued between 0 and 100. We're going to see that. So over here, we can put as a friendly note. Over here, the proportion is this wealth frequency, and typically this will be as proportion. Well, over here, 30% is 1%. Okay, so we have the note there. Okay, how can I make it to this? Well, one thing is I have to call upon a list, but I don't have any list labeled yet. So that's where the flaw is. If I have list labeled like other ones, I could quickly put to a new list. So I'm going to go over here first, and I'm going to go to my data and list, and I have to label C. I'm going to label it. So I'm going to label it L3. Okay, and I'm going to enter it there. So now what we're going to do here is we're going to store. I'm going to show you how to store what we had in the calculator portion over here. But that comes with the whole labeling stuff. So if you want to go that approach, you could do that approach. So I'm going to go back over here to the calculator and notice how it's already done. So there's a store feature over here, right here where bar is at. So I can do Control Store, and it said where I want to store this set to. Well, I want to store it into the spreadsheet. So if I want to go to the list 3 that I created, so I want to store it to L3 that I have already created, and I will enter it. And it says right here, well, here's your list. It has went to L3, and L3 should now be saying this. And let's say that's true. So now I'm going to go back to where the list is, and look, it's right there. So that's pretty interesting. We could definitely do that. But once again, we could also do it in here. If we want to, where the equals is at, we could have done it here. And this would be our list operation. So what we're definitely seeing here is I could do the same thing where I'll put parentheses and I'll put in list 2 because we're getting from list 2. Outside of parentheses, I'll put divided by. But we're going to see something that's very interesting here. So I think right here, it'd be best to have it the other way, but we're going to see what happens. So I'm going to do divided by 2, or divided by 20, because that's what it was, 20. Or you can do the sum of the list if you wanted to, again. But over here, instead of me hitting equals, I'm going to do Control Shift for the approximation. And it should be giving me the approximation right away instead of equals. And let's see if that's true. Control, approximate, and see right here, do I want to refer to the cell? Right here is supposed to be variable, so I'm going to make sure that I do variable. Whenever you do this, and you're doing this operation, make sure it's variable, not cell, variable. Make sure it's variable. Because cell is one particular data. I want all of them to have the effect. So make sure it is under variable, not cell. So now I choose variable and I highlight OK, enter it, and I notice over here, dang, it kept that fractions. Is there a way for me to approximate it so it goes the other way? If not, we're going to keep doing it on the calculator. We know how to do that. So I'm going to see what if I go over here and I approximate them. Nothing happens. Okay. So notice over here, whatever happens if I come over here individually, nothing happens. Oops. Okay. So nothing happens. So when it comes out to this, the best thing for you to do is do it on the other side. Okay, do it on the calculator, and then try and convert it over. Okay, I was afraid this is what's going to happen, that it will just be the fraction format, not the decimal format, and we won't be able to convert it. Me trying to do the approximation is not working. So I know for a fact it's not going to work. Okay. So let me just go ahead and delete this. So once again, how do I delete? Well, I just make sure I have the row labeled, and I'm going to go over here and press menu. I'm going to go to data, and oh wait, not data. I'm going to, okay, oops, I didn't forgot. Oh, sorry, action. I'm going to select, and I'm going to select the column. So the whole column is selected. Now I can do Control clear, and it's gone. Okay, that's how you can do that again. So you're still practicing it. I have to practice more. Still learning this. So I'm learning as I'm teaching. That's the cool part. So I'll come back. But anyways, that's done. So we will say, okay, percentages. How to do percentages? Well, I'm going to show you how to do percentages and convert percentage of proportions by hand naturally, and you can see what kind of special we can put inside here. So you can either say, oh, I can do manually because I know how to convert pretty quick, or I can say I can have time to do it. Okay, and I'll get the proper list. But when you're writing on paper, make sure that you show what it is that you're doing. Okay. Navigation might be a little too hard, so show the formulas and then give me the results. But come over here, I'm going to start with the conversions of percentages. So conversions, and what we're definitely see here is okay. What if I want to go from? Oh wait, first of all, how do I find percentages before I even convert? How do I find percentages? So roster frequencies, percentages. Which we refer to as per much percentage. So when I label it, I tend not to represent that to 5% when I'm doing these. So once again, we know that it came from getting the proportion. Okay, that's how we got proportion in the first place, and we're going to have to multiply it by 1% to ensure percentage. So we're increasing it. So what is this represented again? Once again, this F over N represents proportion or density in this calculator. As it represents. So we're actually getting proportion or times it by 100%. That's what we're really doing here. So let me just go back to the calculator. So I'm going to go back to 1.1. And let's just say I want to get to 0.3. Oh, yeah, there it is. So when I multiply this by times 100%, and there's times by 100, don't put percent in there, and I enter it, I end up getting 3. So how is that working here? So this is where we do the conversion idea. Now, hopefully I have space to do both at the same time. So over here, what we're saying is, if I'm trying to go for proportion, and my goal is to get the percentage, where we know that within the mix, where we are timesing by 100%. Okay, we're multiplying by 100%. So over here we have our 0.3, and we notice that the result ended up becoming 30. So how did this happen? Notice how the decimal got relocated. And what we're seeing here is if I'm multiplying by 100%, I get the decimal and I move to the right 2 units. Because that's how many zeros there are in 100. So the decimal point is now here. Any blank spaces become 0. So 0 goes here, and you can put a 0 here as well if you wanted to. But I don't have the space to do it. Now I do. Okay? So now what we're definitely seeing here is 30.0%, which is the same thing as saying 30%. So that's locate what the calculator is really doing is to say, hey, get a decimal, move it over. And that's what we do by hand in a more efficient way, without having to say, oh, then we put in a calculator times 100, then we put in a calculator again times 100. We can just easily move over decimals, and we're done. I got to show that. So next, what if we're going the other way and you want to find a proportion? Because sometimes you might need to do that. Especially when you get frequencies and you want percentages only. So if you want a percentage and you want to convert it into proportion, notice that we're going to be doing the opposite. So over here, since I'm going opposite direction, I'm going to do the opposite. So if there's a multiplication, that means that over here has to be division. Okay, we'll be back on percent. So let's go ahead and get this 30 and see how it happens. So I'm going to go back the same way. I'll go back the other way. So right here, I was at 30%. So I'm going to get 30% and divide it by 100%. So naturally, these guys were canceled here. And when I put it in a calculator, we're going to see what happens. But this is supposed to be in blue. Let me just rewrite this so it's in blue. Cancel. So now, if I'm going the other way around, and then we just get the 30%, and then we divide it by 100. And see how, once again, we get to this fractional. But once again, I convert that by doing the set the control equals. So control equals gives me an approximation, and I get back to 0.3. So we're clearly seeing here that it ends up becoming 0.3. So we're getting it back. So how is this happening with the movement of decimals? Well, what we're doing here is we're putting the decimal where it belongs, which is after the 30, or after the 0 of the 30. And now what we do is if I move to the right, when I'm making a bigger